The video for you. This is where we're going to take a distribution of scores, and we're going to make what's called a box and whisker plot. And we're going to be able to determine how we're going to be able to find outliers statistically. So without further ado, I will go ahead and do this for it. Let's take test scores. So I've got 100, I've got a 90 or 88, I've got an 87, an 85, an 82, an 80, another 80, 79, 77. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I've got a 20. My goodness, someone did very, very poorly on this. So the first thing I'm going to want to do is I want to arrange this data from lowest to highest. So that's the first thing I'm going to do. So I'm going to take my 20, I'll put it up here, then my 77, and my 79, and then my 80, and then my 80, and then my 82, and my 85, 87, my 88, and then my 100. So now I got all my data nicely arranged from low to high. And the first thing I'm going to find is my median. Median cuts the distribution of scores in half. So there's going to be 50% on this half. There's going to be 50% on this half. So I'm going to have a lower 50%. I'm going to have an upper 50%. And what I want to do is I want to break this down even further. I want to break it down into quartiles. So I want to find Q1, which would be the first 25%, Q2, which would be the second 25%, and from Q1 to Q2 is 50%. So this is going to be my median. That's going to be my median. And then Q3, which would be at 75%, and then Q4 would contain all of my data. So we're going to find that right now. I'm going to give you two examples. I'm going to give you examples where we have even numbers and odd numbers. So let's take a look at this. I want to know what n is. Do that. N. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is a odd or even number. Yeah, it's even. So now I've got data that is split into two halves. I don't have a actual data point that has a median in it. I'm going to have to calculate a median. So I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So my median is going to be right in the middle here. And how I find my median is I'm going to take 80 plus 82, and that's going to be 162. And I'm going to divide that by 2. So I'm going to get my trusty calculator. So I've got 80 plus 82 divided by 2 is 81. And that's pretty easy. I mean, it's pretty common sense. I just want to show you how to calculate it. So 81 is my median, and it's also Q2. So Q2 is always going to be my median. Now I can take a continuum here, and I can make me, a little line graph. So I'll start at 20, since that's my lowest value, and I'll go into 10 digit increments. So 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now it would be better if you went by 5s, but for this demonstration I'll just use 10s. So I've got these points for each one of these points on this scale. Now I know where my median is. It is at 81, so it's just a little bit above 80 here. So I'm going to draw a line. That is Q2. Quartile 2. Now what I need to do is I need to find the median for the lower half of my data, and that's going to be Q1. So I'm going to look at my numbers there. I got 1, 2, 3, 4, 5. oh goodness, I've got a number that's right in the middle. It's 79. So I can go ahead and circle that. I don't have to calculate anything. I can go ahead and just circle it. I got 79. So I'll come in. 79 is almost 80. So it's going to be about right there. So I'm going to have a very, very short box. So Q1 is going to be right there. Q1 is 79. Now, I have to find Q3. So I'm going to do the same thing. I'm going to find the median of this half of the data, and I can see that the middle is 87. So I'll come over here to 85, and just a little bit above 85, I can draw Q3. So Q3 is right there. So I got 50% of all my data already captured. I know my high number is 100, and I know that my low number is 20. But now I got to figure out if I have any outliers. So I'm going to draw a line here, and then I need to determine if I have outliers. So what I'm going to go ahead and do is I'm going to use a method. This is called the Tukey method for catching outliers. So we have what's called an interquartile range. You'll find this in your book. The interquartile range is the range between Q1 and Q3. So I'm going to take the value of Q3, I didn't even put it on there, but it's 87. So I'm going to look at the value of Q3 of 87, and the interquartile range is going to be 87 minus Q1, which is 79. And that's going to give me a value of 87 minus 79 is 8. So my interquartile range is 8. Now John Tukey said that in order to find outliers, we need to use the interquartile range plus half. So 1.5 interquartile ranges is what we need to have in order to cast a net to catch normal data. So anything outside of the net that I don't catch with my Tukey net is considered to be an outlier. So now I need to cut 8 in half, because 1 1/2 IQRs would be 1 1/2. Half of this would be 4. So I'm going to take 8 plus 4 to get my Tukey net. So 8 plus 4 is 12, right? Good. We got the same thing. So this is my casting net. I'm going to stand at Q1, and I'm going to go fishing for outliers. And I'm going to cast my net, or I'm going to cast my net this way, throw it out, and all the data that I catch is going to be considered normal data. Anything that my net doesn't catch is going to be considered an outlier. So let's go ahead and cast the net. I'm standing at Q1, and I know that Q1 is 79. So I'm standing at 79, and I'm going to subtract my Tukey net, which is 1.5 IQRs, which is 12. Whoops. 79 minus 12 equals 67. So 67 is 65, 66, 67, about right here. So my net is only going to catch data right here. So anything left of this data value of 67 is going to be considered an outlier. So I only have one outlier, and that's this value of 20 right here that this net didn't catch.